Right, so we have done some moments in chapter 4. We have done forces and friction in particles and in bodies in chapter 7. Big chapter. But now it's time to move back on to our roots in mechanics, which is what you've learned back in year 1. The first thing you've learned is Suvat. So this chapter is about Suvat. So it's nothing really to do with forces, what you've learned about the F equals ma in x and y direction, restoring forces, that kind of stuff. It's nothing to do with moments. Maybe in chapter 8 there will be some collaboration between two of the topics, but in here is purely Suvat. So while you've learned Suvat in year 1, haven't you? Then why are we going through chapter in year 2? Reason being is we're going to combine the two together. We're going to combine the x direction and the y direction of the Suvat together. So in year 1, just a quick recap. You have learned maybe like a car, okay, start driving from here. There's a driver, and there's also a backseat driver. You know, they always chat or something, and then it's backseat driver. You don't have the right to say anything to me as a driver, or not to me as a driver. Sorry, no personal involvement. Right, and then we've got a traffic light in here. So you've got the red, the yellow, and the green. And then you've learned how to calculate the distance or displacement. Talk about Suvat, we have to talk about each individual one, right? So S stands for displacement, U initial velocity, V final velocity, A acceleration, and T is time. So you would have learned how to calculate using sort of a one-way direction, like a one-dimensional calculation from left to right. All right, or you've learned about throwing some stones up and then coming back down. So initial velocity, final velocity, etc. Now, with the vertical Suvat projectile, this vertical projectile, there's two things that you need to know. One, when you go up, the acceleration is negative 9.8, and when you come down, the acceleration is 9.8. If the particle starts from going up and then come back down, when you use Suvat, you use A equals negative 9.8 because you have to use negative, because if you don't, the particle, if you use positive 9.8 when the particle is shooting upwards, that means you're accelerating as you go up. What does that mean? It's like a rocket, it never comes back down. Sorry, it never does come back down, okay? A rocket without an astronaut, without people driving it, like a robotic ones, may never come down, okay? I did not intend to, sorry, okay. So anyway, so what I'm trying to say is, and the particle go up, negative 9.8, right? For acceleration. What else do we have to talk about? Yes, at the highest point, do you remember what's special about highest point? In the highest point, in a Suvat, the speed is 0. In the highest point, the speed is 0. Well, why? Or velocity, actually. Velocity is 0. Or speed, it doesn't matter in here. The reason being is, as you go up, let's say initial velocity is positive, and then when you come back down, it's negative. So surely from positive to negative, there must be a number connecting them, which is 0. That's why highest point is 0, the speed is 0. We'll come back to this point very soon. So before we move on to chapter 6, then one more thing about the 5 formulae for Suvat. See if you remember. You can pause the video and try to remember the 5 formulae. They are given in a formula booklet, but it's very good to have it in your mind so you don't have to refer back to the formula booklet. So see if you can remember them. The first one, I'll put S equals UT plus a half AT squared. There is a twin equation, which is VT minus a half AT squared. You have V equals U plus AT. You have V equals U squared plus 2AS. You also have the one S equals U plus V times T divided by 2, which we rarely use. The first 4 are the main ones, right? So that's a bit of intro. So let's dive into chapter 6. So what's chapter 6 then? Chapter 6 projectile means, imagine, okay, you are throwing like maybe like a javelin in sports day, or like shot put when you throw something in an angle. So that's you, okay, holding a ball, okay, and then you are trying using all your energy to throw the ball upwards as fast as possible, okay? Now, this kind of motion is called projectile because if you think about the ball, okay, even the person not constipated, but he's trying very hard to throw the ball outwards. He's not constipated. Right, so this ball, okay, if we look at two dimension, one is up and down, the other is the right. Then you can make actually essentially a suivant because you've learned the motion from left to right from this point, from point A to point B. And vertically, the ball starts from here, it climbs to the highest point, and then it comes back down. So isn't that what you've learned in year 1? Because that's a combination of these two. So that's projectile, okay? The main thing about the main exam chapter for chapter 6 will be on these two, 6.3, 6.4. 6.1, 6.2 is the sort of, I guess, is the intro. Let's have a look. 6.1, horizontal projectiles. So as I mentioned, projectile is the motion of an action of a particle being acted on a single force. The projectile is a motion being acted on a single force. So we have seen here that particle, imaginary particle, shooting in that direction. Okay, shooting in an angle. You can see an angle alpha comes back down, etc. So these are what we're looking at in this chapter, projectile. First bullet point. The horizontal motion of a particle is modeled as having a constant velocity, a equals 0. Now, I deliberately didn't write it down, so I want you to change the a or add a little x underneath the a. So it's ax. What does that mean? That means it's acceleration in the x direction. Okay. What it means is, in terms of x direction acceleration, like here, like for example, this car. So back in this car and the traffic light scenario, we're not accelerating or decelerating on the traffic light. We are just having the same speed, constant speed. It's like you're on a motorway, okay? You're constantly traveling as fast as 70 miles per hour. If anyone's traveling 80, that's illegal. But people do break the law. Anyway, so what I'm trying to say is acceleration in x direction means constant speed. We are not speeding up, we're not decelerating, okay? We're speeding, we're not speeding up, so we're not increasing our speed, we're not decreasing our speed either. We're just having constant speed. So in x, traveling horizontally. But for y, the vertical motion of a projectile is modeled as having constant acceleration due to gravity. So this a, add a little y underneath the ay. So that's the acceleration in y direction. That means when you're going traffic up and down, we assume the only thing that is affecting this acceleration is the gravity. So gravity is the only force pulling it. Yeah. Okay. Anything else? Okay. So example number 1. A particle is projected horizontally at 25 meters per second from a point 78.4 meters above a horizontal surface. So we can draw a diagram. Okay, so what it means is we've got a particle in here. It's projected horizontally. That means we're going this way. So a little bit horizontal and then go down. Okay. It's like a bird trying to swoop in to kill a prey. So we have 25 meters per second. That means this here is 25 meters per second. From a point 78.4 meters above the ground, so that's 78.4 meters. Okay. Find the time taken from a particle to reach the surface. So let's call this point A and call this point B. Now, because there are two dimensions in here, one horizontal and one vertical, if one dimension use one suivant, then two dimensions will use two suivants. And hence, the method that we use in projectile is a double suivant. So the way we set it up is like this. X, Y, suivant. Okay. The number one thing that we put in this suivant table in projectile always is true, is AX. That number one thing is always true, is AX is 0. Well, where did it come from? If you've got a pencil or anything, you want to refer it, you can go back to the top. You see AX equals 0, that part. That's the same as here. Right, so AX is 0, we say it. Okay. How about AY? Acceleration of y is gravity is dropping, so it's gravity, so it's positive 9.8, so it's g. Okay, This is G. Right? Again, you can use a pencil to, or again, whatever color pen you want to refer it. So it's this AY equals G in this AY equals G, right? Next, what can we do in here? So let's put in the numbers given by the question. Now let's do a 25 meter per second. This is the initial velocity. Now X means left and right. Okay, Y means up and down. So this 25 meter per second is left and right. So it's X. So this will become the UX, the initial velocity of horizontal initial velocity. English is so difficult sometimes. Next one, 78.4. So we have traveled vertically. So that's the vertical. So something to do with Y is a distance. So it's S in Y, 78.4. 78.4. Oops. 78.4. Right. Now, what else then? Now, I'm not sure if you noticed, every Suvat column, do you know how many information do you need in order to work out a variable in a Suvat? If you don't know, you need at least 3 pieces of information in order to work out an unknown. For example, in this question, if I want to work out time, let's say time in this column, I will need, apart from U, A, I need something like S and V to help me find the T. Or same in the V, in the Y column, if I want to find out T in here, I've got A, I've got S, but I need a U and a V to help me work out T. So in here, there must be a missing information because in either column, I can't do anything. I can't do any work. The trick is in here. When you project it horizontally, that means there's no velocity vertically. There's no velocity vertically. So UV is 0. That's a hidden information. So no, so therefore UY equals 0. The initial velocity of Y direction is 0. Right? Now, with that information, we've got we can use the Y column to help us work out Suvat. To work out time, right? So from Y, okay, so now unlike forces and moments, there are no 3 steps in here. So what you do in the projectile chapter is you set double Suvat and try your best to put in the numbers in the right position in the table. It's all about filling up that table, okay, with numbers. So once you've got A equals G, what we can do is, U 0, 78.4, so we can do Y, I'll just put Y colon, means you're working with the Y, just for your own reference, really, so you know you're working the Y column. The formula that connects S, U, A, and T is S equals UT plus a half AT squared. S is 78.4, U is 0, love it, T is unknown, plus a half times A, which is 9.8 times T squared. 78.4, 0 times T is 0, half times 9.8 is 4.9 T squared. Divide that by 4.9, then square root, T will give you 4 seconds. T equals 4. Okay. T equals 4. So part A done. Part B, find the horizontal distance traveled in that time. Now, in this Suvat table, can you pinpoint which item or which entry in the table, or which gap in the table are they asking you about in this horizontal distance traveled? Yes, you're right. I'm Dora the Explorer. So yeah, work at SX. Well done. Give yourself an applause. Applaud. English. Right. So SX. So what to find SX? So puppy to find SX. You want to find X colon. Okay, that means I'm working on X. So I need to use the same thing because now I know T is 4 from part A. Now, why are the 2 T's the same? Because the 2 T's have to match because it takes A from point A to point B horizontally 4 seconds to arrive, and same with 4 seconds to arrive from vertically. So surely, okay, the time is always the same. You cannot have time different because what it means is if time is different on one, that means you are like a ninja. You have a or split person. I don't know, like a ninja. You have basically a shadow around you, but a shadow is going one. Shadow is arriving slower than you. I don't know if it makes sense. It's a weird thing. Anyway, I'm not talking about supernatural things. So anyway, just move on. Time is always the same. Time is always the same in a super, okay, in this too. So it's always the same. So in an x, we've got s equals ut plus a half at squared. S is unknown, u is 25, t is 4, a is 0. Love it, because I don't care what t is in here. So s equals 25 times 4 is 100 meters. So in other words, from point A to point B, that's 25, that's 100 meters. Right? So yeah, that's, you can see that's projectiles using double super. Happy? Never mind, I'll never hear that. Next example, a particle is projected horizontally again. So this time, today's lesson is always about projected horizontally. So what we know is, that means the vertical velocity is 0. So uy equals 0. Okay, right. So to draw this diagram, essentially, again, we start from here, that way. Okay. If you want to think about this diagram, it's like, you know, there's some cheeky cats, yes. You've got some items in here. I don't have a cat, so I'm just saying it from my personal experience by using Instagram stories or, you know, YouTube shorts, whatever, you know, these social medias. And there's a cat. How do you draw a cheeky cat? You know, they love to push things, okay, over, okay, knock things off. So these things, when they knock off, it's like this. So there's the scenario we're talking about, okay? Unlike what we mentioned very early in the lesson, this kind of projectile moving up, like shooting upwards, like we're throwing a bin bag or doing shot put. That's not what we're discussing here. We'll be discussing that in 6.3. So today we're just talking about things moving off the table, for example. Right, a cheeky cat will go. So what we told, so is moving velocity 15 meters per second. That means 15 meters per second. Oh, that's it. Part A, find the horizontal and vertical components of the displacement from the point of projection after 3 seconds. So let's do it. Projectile method, double super. You know, everything double is good. It's like you go to Mr. Whippy, double is always good, right? Double ice cream, double scone, double flakes. Oh, love it. Double cone, probably not. Sx. So what do we know about anything? So number one thing, first thing we do is the ax is 0. Ay, because dropping, is g, so 9.8. Or you can put g if you prefer. I'll put 9.8 in here. Right? So that's number one thing you do in projectile. Ax is always 0. Ay is always 9.8. Positive or negative, we'll discuss it later. But for now, it'll be always positive. Why? Because you're dropping. When you drop something, the particle is always accelerating downwards to the core of the Earth due to gravity. So it's always positive for now. What else? We know time is 3. T is 3, so given. Ux 15, Uy 0. We want to find displacement, both horizontal and vertical. So that means we want to find these two. Are these two the same? Definitely not. Okay. Well, they could be, but you know, chances are they're not. Like the previous one, you can see. You got vertical height 78.4 and the horizontal distance is 100 meters, so they're not always the same. So to work out Sx and Sy, we'll just have to do it one by one. Let's do x first. So to do x, I need to use the one without v formula. So S equals ut plus a half at squared. S is unknown. U is 15. Time is 3 plus a half. A is 0. Time is 3 squared. Half times 0 times 3 squared is just 0, so it's gone. 15 times 3 is 45 meters. So that's horizontal distance. What about vertical distance? Well, again, same equal S equals ut plus a half at squared. S is unknown. U for y is 0. So u for y is 0. Time is 3 plus a half times A is 9.8 times 3 squared. Well, half times 9.8 is 4.9. 4.9 times 3 squared times 9 is, well, 44.1. Mental maths. That's easy. No, I'm just kidding. I've got my answer in front of me. So, right, so that's the answer. Part A, 44.1. Question A, done. Right, horizontal and vertical components, we've done that. Part B, find distance of the particle from the point of projection after 3 seconds. Right, So what's the difference between distance and displacement? Now, what we're told is that's 44.1. That's 45 meters. That's what we found out in part A. Distance is if you use a ruler and make a straight line from point A to point B, that's your distance. What do? Pythagoras. So part B, distance. So you can use this. So that's 44.1. That's 45 meters. If you want to, you can put SX and SY in here just in case you're wondering. Then that's put a straight line. That's your distance. Okay. So the distance therefore equals square root of 44.1 squared plus 45 squared. Mental maths, well, really easy. Let me try to calculate in my mind. Oh, yes, 63.0 meter per second. Sometimes I'm impressed. Oh, meter per second? Meter, sorry, I was too focused on the mental maths. Doing 44.1 squared plus 45 squared, the square root in my brain. Sorry, too much calculation. Sometimes I wonder, I'm amazed by my own mental maths skills, also known as cheating and using calculator. Right, so 63, anyway, so that's the distance. All right, is there one more? Yes, a treat, one more for you. A particle this time is projected horizontally with a speed u meter per second from a point 122.5 meters above the horizontal plane. So maybe we can do that. Okay, so that's the particle. So the plane here doesn't mean aeroplane. It means like a geometric plane. It's like the XY coordinates. That's a plane. Okay, so we're not talking about aeroplane in here. So 122.5 is that one. If you find it silly, I actually had a student asking me before. What else? We're told u meter per second is traveling horizontally. Actually, I should have drawn this a bit better. By specifying, we start from in horizontal projection. So u meter per second. Again, horizontally, that means uy is 0. Next, particles hits the plane, and then this plane, another plane, okay? At a point which is horizontal distance, 90 meters away from the starting point, so that's 90 meters. Find the initial speed of the particle. Now, what I want you to do is, I would like you to set up a super table. See if you're able to put in the numbers, what I've taught you in the previous two examples in this table. Okay, pause the video, try to fill up the table yourself first, because that's a most important skill in this chapter. When you're ready, you can press play. So the first thing we'll do is AX being 0, AY is 9.8. I've told you that many times. Many times means 2 times, because I've gone through 2 examples. Next, these distances, that's horizontal distance 90, can be put in here, and SY is 122.5 there. UX is U, UY 0. So that's a complete table. Now, you'll be thinking, how do I find U then from here? Because if I need to find U, or if I want to use a column in here, I need 3 pieces of information. I've got 90, I've got 0, but I've got nothing else. But on a Y column, which I don't have any other variable, because U is not on the Y column, but I've got 3 pieces of information. So what we can do is, we can first work out T, and then bring the T over to this column, and then we can find U. So that's our game plan. Okay, so on Y, let's start with that. S equals UT plus a half AT squared. S is 122.5. U is 0 times T plus a half times 9.8 T squared. So do 122.5 equals half times 4.8, 9.8 is 4.9 T squared. So T equals square root of 122.5 divided by 4.9. Mental maths again. 5 seconds. So once we found T equals 5, we know that's 5. Perfect. Then we can use the X column to help us to work out the U. So in the X column, S equals UT plus a half AT squared again. S is 90, U is U, T is 5, U is U. this stay in front of English teacher, I think you get detention. A is 0, t is 5 squared. So 90 equals 5u, u equals to 18 meters per second. Okay, but that's velocity, right? So what's the speed then? The speed, so speed, if I ask you, for example, if I tell you v equals 3i plus 4j meter per second squared, what is the speed? What is the speed? How would you work out speed? 3i plus 4j means 3 going right and 4 going up. That's the speed in here. That's the resultant force, similar to resultant force. So essentially it's 3 squared plus 4 squared, right? So in this case, where's your I and j? Your I and j is like your x and the y. So what you've calculated velocity, right? Actually, so velocity is 18i plus 0j. So the speed, therefore, is square root of 18 squared plus 0 squared, which is 18 meters per second. Now, the reason I have to go through this is because later when you have the y not being 0, you can see in here these questions, chapter 6.1, the uy is always 0. When uy is not 0, then the speed will be different. But for now, it will be the same as the horizontal velocity. Okay, that's the of 6.1. Right, so what you've learned today, double soup up. First thing you do, AX 0, AY 9.8. Next thing, based on what you're given from the question, you put it inside. For this particular chapter 6.1, UY is being 0 at all times. All right, so have a go in the practice, and I'll see you next time.